Hello everyone, you're welcome to our class today, our chemistry class today. Today we are going to clear a very common confusion in chemistry. And what exactly is this? It's different between strong acids and weak acids. So we have to compare, we're trying to compare side by side differences between strong acids and weak acids. Let's start with the first one, ionization. Strong acid ionizes completely, 100% in solution. Weak acid ionizes partially, less than 100% when they are dissolved in solution. Now, in representing the equation for strong acid, we use a single arrow, just one arrow, to show that it's a strong acid. And for weak acid, we use a reversible arrow to show that this is a weak acid. Then in terms of hydrogen ion concentration, because acid, when they are dissolved in water, they produce hydrogen ion. So the concentration determines if it's a strong acid or a weak acid. So when you have high concentration of hydrogen ion, then it is a strong acid. When we have low concentration of hydrogen ion, then what you have is a weak acid. Then the pH of strong acid are usually very low. They are typically less than 3. Note that the pH ranges from 1 to 14. So acid lies between 1 to 6. So for strong acid, it is usually less than 3. Then for weak acid, it's usually between 3 to 6, the pH value. Then conductivity. In terms of conductivity, strong acid have high conductivity. They are better conductors when compared to strong acid, which are low conductors of electricity. Then these are common examples of strong acids. We have hydrochloric acid, one. We also have sulfuric acid. We have nitric acid. These three are the common examples of strong acid that we have. Then for weak acids, we have ethanoic acid, we have carbonic acid, we have citric acid. These also are common examples of weak acid. Then common examples of weak acid. Now in terms of prevalence, how common they are, we have very few common examples of strong acid. Few common examples of strong acid. One, for weak acid, most acid in nature are weak acid. Most acids in nature are weak acid. We have citric acid is from citric fruit. We have lactic acid from milk. We have amino acids from protein. These acids are examples of weak acids. Then the Ka value of strong acids is usually very high, usually greater than 1, while the Ka value of weak acid is usually less than 1. Quickly, let us compare in terms of conductivity for strong acid and weak acid, and let's see which of them, to demonstrate which of them is a better conductor. So look at my screen here. As you can see on the screen, so we have strong acid. This is a strong acid. Now let's see how it will conduct. Let's compare the conductivity of strong acid to that of weak acid. Let's see how it works. So if I insert this my electrode into the strong acid, you see what happens. Immediately the bulb glows very brightly because it ionizes completely and a better conductor of electricity. So let me remove it and change it to a weak acid. You see the particles also change. They have less concentration of the hydrogen ion. When I start it, let's see what happens. Will it also glow brightly like the strong acid? Look at it. As I started, look at what happens. It does not glow brightly. It's dim. It shows that weak acid have low conductivity. They conduct less when compared to strong acid. Why? Because they ionize partially. And because they ionize partially, electrons will not flow easily and the bulb will not glow brightly. So these are the differences between strong and weak acid. As you can see, strong acid conducts better, high conductivity than weak acid. So far, we are able to differentiate between strong acid and weak acid. So if you asked, difference between strong acid and weak acid, I believe you have been able to understand the difference between them, and you should be able to differentiate between strong acid and weak acid. So thank you for joining us today. In the next class, we're going to look at conductivities of various strong acids in terms of maybe the concentration changes. How will the conductivity look like? How will it conduct in terms when the concentration changes? So we'll look at this in the next class. So hope you see you next time.